the title, so high mechanical loading for high performance demands, says a lot to myself also, because that means that the introduction of those machines for sprint training, but also, or especially in my case, for strength training, is really has been important. We're all looking for high mechanical loading, but it's not so easy to access. And I will show you some examples how we do that. We will do some practical with one demo athlete, but I will show you a bunch of videos. But I also want to explain you why different modes that we can use with those machines are important for us. What for me is important is, okay, what does that mean, that drop in velocity or the velocity itself? We have a part that is clearly rated to strength adaptation. This normally doesn't go to muscular failure. And we have another part, it's called hypertrophy. It's better if it goes to muscular failure. Not all the time, but it helps. Especially, I think, if we're talking about eccentric training, it's maybe even more important. Okay, so I think most of you are knowing that concept. This here is bench pressing. You see this 14 repetitions, so this is moderate loading. But what you can see actually on the X graph is the time used for the repetition. So you see repetition 12, 13, 14, it's getting up with the time under tension. And this is the point that I try to hit for hypertrophy. Okay, just that you get an idea what it is if you talk about time under tension. So what is needed for hypertrophy? High mechanical tension, so high load or high fatigue at the end. In this case, it's high fatigue that leads to high mechanical tension. But then the time spent under that high mechanical tension, this is important, and this is not so easy to get. Because as you see in this example, we have a bunch of chunk volume to get to that point. Yes, we can do it also with heavy loading, as you have seen in the first example, but then, yeah, you have to carry the weight. And it's heavy and it's demanding also from a mental perspective, right? And this is where I would say the isokinetic training mode comes into play. So this is what we can have with the 1080 motion devices, the isokinetic training mode. And if you see here, by doing this, yeah, you get here a lot of force production, because if you move slowly, isokinetically, there's quite a long time under tension, but with full activation through the full range of motion. And if you do that right, so you will definitely have a long time where high muscle fiber force is acting on the tissue, which is also very important. So now we are just going for full range of motion squatting. What is the minimal velocity threshold in squatting? Come on, meters per second. It's a bit too low. Yeah? Yes, 0.3. Okay, not for all of the people or athletes, depending on the different profiles. But generally said, okay. So now we make him work through this velocity in isokinetic mode. So that would represent 1 RM repetition, but from the very beginning. Okay. So ideally you can have the handles here, come a bit closer to the line. You squat down. It's easy. You go down, and then you try to push. Okay. Just go out of. Don't go to that deep. No. Yeah, it's just a question of calibration. You go down, you make some repetitions, and you push. Okay. Go on. Okay. Go on. No. Okay. Okay, very good. How does that feel?
Good.
Heavy or not?
Not the heaviest, no.
Not heavy?
Well, a little bit.
You have to push more? Okay, 5 reps. 5 reps in a row.
Hands on me.
Yes, you really give full intention in a concentric way. Huh? Okay. Allez, push, 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 push. Okay. Allez, push, 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 push. Allez, push, 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 push. Okay. Allez. Okay, good. Okay. Now it looks better.
Yeah.
So intent is key. Yeah. Intent is key. I mean, you can, depending on the load, you can just follow the velocity. But it's all the time it's the same with the VBT approach. Intent is important. Okay, so this would be a way to go to this 1 rem velocity. So this would be the highest stimulation velocity for hypertrophy. But there is actually no load into the game. It's only velocity barrier that is creating this tension. Okay. But coming back to this hypertrophy point of view from the beginning, you may have seen that at the last couple of years, lengthened partials have been a bit become popular. And there are a lot of reasons why it works. So that means that you don't do the full biceps curl, you would only stimulate at the very end. Okay? So if you go back to the machine here, demo athlete ready. So now time under tension will be reduced because he has a smaller range of motion. So what I will do now is I adapt the velocity. So we will, yes, for sure. So we will go down to 0.1. Now it's very, very slow. But as the range of motion is limited, it adapts just to correct for the time under tension. So now what you will do, you only work on the lower third of the movement. That's the same intent. I'll try to stabilize the plate here, so you go down. Maybe he needs a bit more of eccentric load here. It's not dangerous. Don't be afraid. More is better. More is better. Yeah. Okay. So you follow the way down. You know, pull and go down. Pull and go down. Pull and go down. Okay, thanks. It's good enough for the day. Okay. But you also, I mean, it was a good example also that you have to get used for this type of squatting. Okay, for me it's good. I've seen enough. It's good. You can, yeah. Just take him out here. So that means again you have to prepare your athletes for that kind of training. And I personally prefer the synchro, the quantum synchro, because then you go under a normal squat rack and you can much better fix stabilization and just tension generally to do that kind of work. Okay, just that you understand the context. But it's more about understanding. Okay, why can isokinetic training be so interesting? What do you have to take care about? And this is not only for the training, for the healthy training mode. It's very interesting also for the rehab mode, where you cannot add loading, but you can give them the chance to highly stimulate at the angles they're able to stimulate at that particular moment. What's often the problem in normal training is that the force velocity curve of your load you're using in like normal squatting, it's only for the concentric side. It's not the same for the eccentric side, because eccentric contraction is much more efficient. So there also, and this is another big potential, I would say, of those machines, that you can do a phase-specific loading. So you can add load on the eccentric side to correct for this efficiency difference. This also may be definitely relevant for hypertrophy, but not only. But now this is the more interesting part of eccentric training, fast eccentric training. Okay, the heavy loading, you know, people sometimes are afraid to do it because they all the time think of 300 kilogram barbell on the neck, but people all do Nordic hamstring curls. So Nordic hamstring curls naturally for most of the athletes is kind of supramaximal eccentric training. So just be aware of that. But now these are the two functionalities of eccentric muscle contraction. So on the left side here, and this is just an example where we combine like AEL with drops, just to show you. And here also we run a study some years ago. So now we're using the 1080 motion machine to replicate exactly what you've seen before. So the machine is pulling down with more load as on the concentric side, and you have the chance to do that in repetition, which is not easy. If you have dumbbells in your hand, you drop down, you have to pick them up, go up again, and so on and so on. And at the same time, you get data to decide, okay, what's the ideal load, are we progressing or not, and so on. What we measured actually is just, we compared 3 different conditions. If you have an equal loading, if you have a 1-to-2 ratio, or a 1-to-3 ratio. And which is logical, this is the red line here. With the 1-to-3 ratio, we had the highest eccentric forces. But in that particular moment, I'm only interested in the high eccentric forces. So I want to have high and create high braking forces in the smallest amount of time. So I often choose the 1-to-3 ratio, and I then go up by the loads just progressively to bring people up there. If people is not that used at the very beginning, so you can start with slower ratios like 1-to-2 just to get them used a little bit. What we also saw is that the very first jump, you know, when you're standing on a plate and you're going off like that, is not the same as the one when you're coming down from the fall height. And you see that here. So the black line is just a normal counter movement, and then it starts to go up on the second jump. You also see in the red line that at the 6th jump, the braking forces are already a bit lower, because if you go with that intensity, fatigue accumulates quite rapidly. So that also means, again, that the volume is rather low when you're using this type of training. You just feel what the machine is doing. Just stay at the right place then, please. So you just do normal counter movement jumping, just that you feel what the machine is doing. Yeah. Go a bit more to the front, maybe. Yeah. Just some couple of jumps here. Bam, bam. Okay, good. Now we give him, so this was 1-to-1 equal loading. Now we give him a ratio of 1-to-2, I think. He will be able to do that. Yeah, 6-to-8, go to 6-12. Okay, now is a bit more load pulling you down. So just go easy, maybe at the very beginning, so not that depth, and just a bit of jumping.
How many do you want me to do?
Yeah, maybe 6. Just to feel a little bit. Tack, tack, tack. Okay. Okay. Good. Okay. You felt the difference?
Yeah.
Yeah. Okay. You want to see 1-to-3 ratio?
Yeah.
Sure.
What load are we doing right now for the people in the back? What are our settings?
So now we are 6 kilo on a concentric way, and we have 18 additional on this way.
And now, So 6 and 12, and now we're 6
Okay.
and 18 and 6. Thank you.
Just 3 jumps,
Three jumps.
to feel it. Okay.
Oh, where isn't it?
Okay. What do you feel?
Good.
Yeah. Tough to break, or
That was hard.
still okay?
That's still all right.
Yeah. Okay.
Jan,
Will we go up?
what metrics do you care about when you do this? Concentric or eccentric?
Both. Both.
And do you look at a specific?
No, but normally, no, both. Yeah. It's
Speed specific?
Yes, often it's the easiest way to adapt if you go for like concentric output. Yes. Eccentric metrics not always easy to capture, I think. Yeah. So how much more will we give him? 10 down? No, 10 up, 30 down? Yeah.
Do you always load the concentric phase? If you do,
This is, okay, I'm allowed to say that it's a limitation because if you go up with the eccentric load, the ratio stays the same, so the concentric load comes up also. So that's also why you don't go too high, because if not, you cannot push as effectively anymore. So maybe
there is a ratio built into the machine of 1 to 3, because it's also technically it's hard to handle a ratio 1 to 10 in the change of direction. So that's why we have. So that's why we do the always 1 to 3 is the maximum ratio. So, but we can still do 10 and 30.
Yeah, you have to.
Because
No, okay.
It's Friday.
Yeah.
Let's go.
So just
Come on.
yeah.
Let's go.
Four jumps, huh? Four jumps. Yeah.
Okay.
Okay.
For the win.
Am I going to come off the ground? Or?
We'll see.
Yeah, I think so.
Hope so.
Got it.
One more try.
Got it. Got it. 3, 4. Oh, okay. Okay. Great. Now, just go and do some normal jumps there. 4 again. Touch the ceiling. Let's go. Okay. How does that feel? Easier. Okay. But this is also a type of work we're doing sometimes, the contrast loading like that. Okay? Because I think potentiation may be really, really interesting from that kind of stimulation.